Okay, higher homework A, question 1. The point A with coordinates 1, 6 and the line PQ has the equation 2x minus 5y minus 1 is equal to 0. Part A says find the equation of the line which is going through A and perpendicular to PQ. Okay, so there's PQ and there's a representation of that line with 1, 6. Okay, so I need point gradient. There's the point, so I need to get the gradient. First of all, I need to find the gradient of PQ, so I need to write this thing in the form y equals mx plus c. So take the minus 5y across, that'll be 5y is equal to 2x minus 1, and y is equal to 2/5 x minus 1 over 5. So the gradient then of that line is 2/5. So m1, m2 equals minus 1. Flip and invert, and the gradient of the line which is perpendicular then is minus 5 over 2. So the gradient is minus 5 over 2 and the point is 1, 6. Y minus b is equal to m bracket x minus a. That's y minus 6 is equal to minus 5 over 2 bracket x minus 1. 2y minus 12 is equal to minus 5 bracket x minus 1. 2y minus 12 is equal to minus 5x plus 5. Bring that across and that's 2y equals minus 5x plus 17. Okay, part B is now looking for the point of intersection of both lines. So that's going to be simultaneous equations. So my first equation is 2x minus 5y minus 1 is equal to 0. And my second equation then is this one, which is 2y equals minus 5x plus 17. Okay, so let's just rearrange one of these ones in. So let's bring that over, so that'll be 5x plus 2y is equal to 17. That's me rearranged equation 2. And line equation 1 up there, so 2x minus y is equal to 1, that's equation 1. Okay, so I could get rid of x's or y's. I'm going to get rid of y's in this case, so I'm going to scale these up to 10, multiply that equation by 5, that equation by 2. Okay, so that will give me 25x plus 10y is equal to 85, and that will be equation 3, and then this one will be 4x minus 10y is equal to 2, and that's equation 4. Signs are different, so I'm going to add, so that will be 3 plus 4, 25x plus 4x is 29x, these cancel out, that will be equal to 87. X is equal to 87 over 29, 29 goes into 87 3 times, so x is equal to 3. Okay, I'm now going to sub x equals 3 into one of the equations to get y, so I'm going to sub it into equation 2 up here. So 2y will be equal to minus 5 bracket 3 plus 17. 2y is equal to minus 15 plus 17. 2y is equal to 2 and y is equal to 1. So the point of intersection then is given by 3, 1. Okay, question 2, I've got f of x is equal to x over 1 minus x and g of x equals 1 over x. Question asks me to find, first of all, g of x. Okay, so that's g of 1 over x. Okay, the g function is whatever's in the bracket is on the denominator with a 1 up top, whatever's in the bracket is on the denominator with a 1 up top. Okay, so that's going to be 1 times x over 1. That's me bringing this up, flipping it over and multiplying. They cancel out and I get x. Next question is looking for f of x. So that's f of x over 1 minus x. Okay, the f function is whatever's in the brackets on the numerator and on the denominator with a 1 minus beside it. So whatever's in the bracket is on the numerator and on the denominator with a 1 minus beside it. Remember to get that into brackets there. Okay, so that's going to be x over 1 minus x. Remember that anything divided by itself is equal to 1. So I could then write 1 as 1 minus x over 1 minus x, which then gives me a common denominator. Okay, so that's x over 1 minus x over, well, we've got 1, we've got a minus x and a minus x, that's minus 2x over the common denominator of 1 minus x. I'm going to change this divide to a multiplying, flip the second fraction upside down. X over 1 minus x multiplied by 1 minus x over 1 minus 2x. These two cancel and leave me with x over 1 minus 2x. Okay, question 3, we're going to evaluate some definite integrals. The first one between 2 and minus 2, which is 2x plus 1. Okay, so remember that I'm adding 1 onto the power divided by the new power, so it's 2x squared over 2. Remember that a constant, when you integrate it, becomes constant x, so 1 becomes 1x. Between 2 and minus 2, I'm going to then simplify that down, and that's going to be x squared plus x between 2 and minus 2. Okay, so that's going to be 2 squared plus 2 minus 2 all squared plus minus 2. Okay, so that's 4 plus 2 minus 4 minus 2, and that is 6 minus 2, which is equal to 4, question B. And I'm going to integrate between 3 and 1, x squared minus 1 over x squared. The first thing that I need to do is prepare to integrate this one. X squared is fine, but bring that up, and that will be x to the minus 2. Okay, I can now integrate, add 1 to the power, divide by my new power, that's x cubed over 3, minus x to the minus 1 over minus 1, between 3 and 1. Okay, I can definitely tidy this up. Okay, so that's going to be x cubed over 3, the 2 minus 0 will give me a plus, so that's plus x to the minus 1. I can then bring that back down, x cubed over 3 plus 1 over x to the 1, that's x between 3 and 1. Okay, let's do the substitution, so it's going to be 3 cubed over 3 minus 1 over 3 minus, open up, 1 cubed over 3 plus 1 over 3. Okay, 3 cubed is 27, 27 divided by 3 is 9, 9 minus 1/3, minus 1/3 plus 1/3. Okay, so I've got 9 minus 1/3 minus 2/3. So that's 9 minus 3/3, 9 minus 1, that's equal to 8. Okay, question 4, we're calculating the area between the parabola and the straight line. Okay, the parabola was given by y equals x squared, and the straight line is y equals 2x. Okay, so it's going to be upper minus lower, so the upper function is straight line and the lower function is the parabola. Okay, the first thing that I need to do is to get the limits, so I'm going to make y equal to y, x squared equals 2x, x squared minus 2x is equal to 0, x bracket x minus 2 is equal to 0, x equals 0 and x equals 2. So that's my limits. So between 2 and 0, and it's going to be upper minus lower. Okay, so between 2 and 0, the upper function again is the straight line, so that's 2x minus the lower, which is the parabola, x squared. Okay, then I'm going to integrate. Okay, so add 1 to the power, divide by my new power. between 2 and 0. I can then cancel those. So it's going to be x squared minus x cubed over 3 between 2 and 0. Okay, so that's then 2 squared minus 2 cubed over 3 minus 0 squared minus 0 cubed over 3. So that's 4 minus 8 over 3 minus, this all collapses down to 0. So 4 can be written as 12 thirds. 12 thirds minus 8 thirds, and that's equal to 4 thirds. Okay, question 5. We've got x squared plus m plus 1x plus 9 equals 0. Find m given that the thing has got equal roots. Okay, so first of all, let's get a statement down. B squared minus 4ac equals 0 for equal roots. Okay, so that'll probably get a communication mark, an interpretation mark. Okay, let's identify a, b, and c. A is 1, b is m plus 1, and c is 9. So it's going to be m plus 1 all squared minus 4 times 1 times 9 is equal to 0. That's m squared plus 2m plus 1 minus 36 is equal to 0. M squared plus 2m minus 35 is equal to 0. Two numbers that multiply give minus 35. I together give 2 is 7 and minus 5. Okay, so that's m plus 7 is equal to 0. M minus 5 is equal to 0, which will give me m equals minus 7, or m is equal to 5. Okay, question 6. We've got f of x is equal to 5x cubed minus 3x to the 5, and the question is looking for us to find the coordinates of the stationary points and determine their nature. Okay, so let's differentiate. 15x squared minus 15x to the 4 is equal to 0. Okay, so f dashed x equals 0 for stationary points. So let's take out the highest common factor of 15x squared. Bracket 1 minus x squared is equal to 0. I've then got 15x squared is equal to 0, and 1 minus x squared is equal to 0. So that's x squared equals 0 and x equals 0. I've then got a difference of 2 squares here, which will give me x equals minus 1 and x equal to 1. So I've got 3 stationary points, 1 at minus 1, 1 at 0, and 1 at 1. Okay, let's establish the y coordinates of the stationary points. So f of 0, that's 5 lots of 0 cubed minus 3 lots of 0 to the power 5, which is equal to 0. Okay, so stationary point 1 then is the origin 0, 0. F of minus 1 is equal to 5 lots of minus 1 cubed minus 3 lots of minus 1 brought to the power 5. Minus 1 cubed is minus 1 times 5 is minus 5. Minus 1 brought to the power 5 is minus 1 times minus 3 is plus 3, and that is minus 2. Stationary point 2 then is minus 1 minus 2. Okay, third one. F of 1 equals 5 lots of 1 cubed minus 3 lots of 1 to the 5. That's 5 minus 3, which is equal to 2, so stationary point 3 then is 1, 2. Let's determine the nature. So to determine the nature, we need to set up a nature table. Okay, so x, f dashed x, and slope. Stationary points exist at minus 1, 0, and 1. So I need to investigate what's happening before, between, and after. Okay, so neighbouring values could be minus 2, minus 0.5, and 2. I'm investigating the gradient, so that would be investigating the differentiated function, which is up here. Okay, so let's first of all try what's happening at minus 2 for the gradient function. So 15 lots of minus 2 squared minus 15 lots of minus 2 to the power 4. Okay, minus 2 squared is 4. 4 times 15 is 60. Minus 2 brought to the power 4 is 16. And then 16 times minus 15 is going to give me minus 240. Okay, so the important thing then is that is a negative result. And the curve is going down the way. I've got zero gradient here, here and here. Let's now investigate what's happening at minus 0.5. So it's going to be 15 lots of minus 0.5 squared minus 15 lots of minus 0.5 to the power 4. I think you'd get a calculator for that one, so enter that in the calculator. Okay, so that will be 15 lots of 1/4 minus 15 lots of 1/16. So 15 over 4 minus 15 over 16. That will be 60 over 16 minus 15 over 16, which is 45 over 16, which is a positive result. Let's now investigate what's happening at 0.5. Okay, so that will then give me the exact same result, which is positive. Okay, so the curve is going up. Let's now investigate what's happening at 2. So 15 lots of 2 squared minus 15 lots of 2 to the power 4. Okay, 2 squared is 4 times by 15 is 60. 2 to the 4 is 16. 16 times 15 is going to be equal to 240, and that's going to be minus 180, and curve is going down the way. Okay, so I can now determine the stationary points. First of all, I've got a min turning point at minus 1, minus 2. I've then got a rising point of inflection at the origin, and finally a max turning point at 1, 2. Okay, question 7. X minus 1 is a factor of the polynomial x cubed plus kx squared plus 5x minus 14. Find k, then factorise the thing fully. Okay, so that means 1 is a factor. My coefficients are 1k, 5 and minus 14. Okay, 1 times 1 is 1, that's k plus 1 times 1 is k plus 1. K plus 1 plus 5 is k plus 6. K plus 1 times k plus 6 times 1 is k plus 6. K plus 6 minus 4 is k minus 8, which must be equal to 0, since x minus 1 is a factor, which means k is equal to 8. Okay, I can now factorise the thing fully. So I've got x minus 1 from up here. I've then got x squared. K is 8, so k plus 1 must be 9, so that's 9x. K is 8, so k plus 6 must be 14. And that's x plus 7 bracket x plus 2. Final answer, x minus 1 bracket x plus 7 bracket x plus 2. Okay, small one marker to finish. It says solve the equation for it being equal to 0. X minus 1 is equal to 0. X plus 7 is equal to 0. X plus 2 is equal to 0. X equals 1. X equals minus 7 and x equals minus 2. Okay, question 8, we're looking to write the exact value of sine 5 pi over 3. Okay, pi over 3 is 60 degrees, so this is sine 150, so I'm going to be thinking in degrees but writing in radians. Okay, so we're out with 0 to 90, 0 to pi over 2, so let's get the cast diagram down. Okay, so 150 degrees, 5 pi over 3 is going to lie in the sine quadrant. That means it's going to be a positive result because sine is going to be positive in there. The acute angle in there is 30 degrees, that's pi over 6. And sine pi over 6, sine 30 is equal to 1/2. Okay, next one is tan 7 pi over 4. So pi over 4 is 45. So 7 lots of 45, and that's going to be 315, tan 315. Okay, so I'm thinking degrees but writing in radians. So 7 pi over 4, 315 is going to be in the cosine quadrant, so tan is going to be negative. The acute angle then is 45 degrees, pi over 4. Tan pi over 4, tan 45, that's 1, so that's -1. Okay, question 9. We're going to solve between 0 and 360. 2 sine x plus 1 is equal to 0. Okay, so that's 2 sine x is equal to -1 and sine x is equal to -1 over 2. Okay, so let's change that to a positive result, but look, not on all in sine, but cos and tan. Okay, so x equals sine inverse 1/2, that's 30 degrees, but I'm in the tan in the cosine quadrant, so cross that out, and in the tan quadrant that's going to be 180 plus the angle of 30, that's 210, and in the cosine quadrant 360, take away the angle of 30, which is 360, take away 30, 330, final answer. Okay, question 10, we're going to show that y equals -3x minus 10 as a tangent to the circle x squared plus y squared minus 20y plus 60 is equal to 0, and find the coordinates of the point of contact. Okay, so let's sub y into that equation, x squared plus -3x minus 10 all squared minus 20 bracket -3x minus 10, close the bracket, plus 60 is equal to 0. So it's going to be x squared. Just take your time with that. If you need to go to the side and take your time with it, then that's what we do. 9x squared minus 3x times minus 10 is 30x plus another 30x plus 100 plus 60x plus 200 plus 60 is equal to 0. I then get 10x squared, 60x, 120x plus 120x plus 360 is equal to 0. Now, two methods of proving tangency here is to use discriminant or factorise the equal roots. The advantage of factorising equal roots is that also takes you in the journey to the point of contact, so I'm going to go for that. First rule of factorising, take out a highest common factor, so it's going to be 10 bracket x squared plus 12x plus 36, close bracket is equal to 0. I can then divide both sides by 10, and that will bring me down to x squared plus 12x plus 36 is equal to 0. That will be x plus 6 bracket x plus 6, which is x plus 6 all squared. So x equals -6, equal roots. Therefore, tangency exists. Okay, get the point of contact. I'm going to sub x equals -6 into my equation for y. So that equation then was y equals -3x minus 10. So that's -3 bracket -6 minus 10. That's going to be 18 minus 10, which is 8. So the point of contact then is -6, 8.